This video goes over division of polynomials using synthetic division. So this is a bit of a shortcut that is going to work if you are dividing by a linear factor. So let's take a look at how it goes. So we're going to set up our division question. Instead of going up and to the right, we're going to go down and to the right, and we're going to list just our coefficients across the top. On the left-hand side, I'm going to put my divisor, but I'm going to put the 0 of my divisor. So if I'm dividing by x plus 4, I'm going to put minus 4 outside of the brackets. And then I'm going to bring my first one down. This is like my freebie. And then I'm going to multiply through. So minus 4 times 5 is minus 20. And then instead of subtracting that I was doing when I had all my coefficients, I'm going to add them together. So minus 14 plus minus 20 would be minus 6. And then I'm going to multiply through again. So minus 4 times minus 6 gives me positive 24. And then I'm going to add those two together to get 35. Now, in order to figure out which coefficients and exponents go in my answer, I'm going to start from the right-hand side. The rightmost term is my remainder. My next term would be my constant, and then my next term would be linear. So that means that this expression, the 5, the minus 6, and the 35, would be 5x minus 6, remainder 35. So I can write my division statement as x plus 4 times 5x minus 6 plus 35. Let's try another example. I'm going to set up my division statement, set up my coefficients, and I'm going to make sure that I put them in descending order. So my first one is a 1, goes with that x cubed. Then I've got 3, minus 1, and 8. And then I'm going to take my 0 of my divisor, so minus 1. And then I'm going to repeat the process. So I bring down the first one, then I multiply through, then I add my next column, multiply through, minus 1 times 2 is minus 2, and then I'm going to add them together. Minus 1 times minus 3 is 3, add them together, I get 11, and then I start with my rightmost term as my remainder, and then I've got my constant, my linear term, and my quadratic. So to summarize, I'll write my division statement as my divisor, x plus 1, just from the question. My answer, so x squared plus 2x minus 3, and then plus 11 as my remainder. So let's keep going. We'll do a couple more examples. So set up my division here. I'm going to put the coefficients in order. So I've got 1 for y cubed, minus 4 for y squared, minus 2 for y, and then 8. And then I'm going to put my 0 outside. So I've got y minus 4, so then I put plus 4 outside. Bring down the first term, then I'm going to multiply through. 4 times 1 is 4. Then I'm going to add the next column together. Minus 4 plus 4 is 0. And then I'm going to multiply through. 4 times 0 is 0. And then I'm going to add them together. Minus 2 plus 0, minus 2. One more time. 4 times minus 2 is minus 8. And then I'm going to add them together. My rightmost term is my remainder. It's 0, which means that y minus 4 must be a factor of my dividend. And then I've got my constant term, my linear term, and my quadratic term. So when I write my division statement, I will say f of x is equal to y minus 4 times x squared minus 2, and then there's no remainder. And since my variable is y, I should probably use y for my answer here. And I'll just change these to y's. There we go. So now you can see that we factored my cubic polynomial. I really have two factors here. I've got a linear factor and a quadratic factor. Let's do another example. So we'll set it up with our coefficients, -9, -25. And then we've got our 0 outside, so +3. So I bring down my first one. I'm going to multiply through. 3 times 3 is 9. Add the next column together. 3 times 6 is 18. Add the next column together. 9. And then 3 times 9 is 27. -25 plus 27 would be 2, which is my remainder. And then I have my coefficient, my linear term, and my quadratic, which is going to let me write my division statement. Is x minus 3, 3x cubed minus 3x squared minus 9x minus 25 plus 2. If you ever had a dividend that didn't have all of the descending powers in order, so let's say there was no x squared term, you would have to add a placeholder just like you do in regular long division. We're going to do two more examples here. Both are special cases. So this one we're dividing by a factor that doesn't have a whole number as a 0. So if I set this one equal to 0 and I solve for x, I'm going to get 5 over 2. So what that means is that I'm kind of artificially changing this question so that my 0 bracket looks like the other ones that I've started with. When I do that, I have to add one more step. I've sort of multiplied artificially by 2 by factoring this bracket to look like the bracket, which means that at the very end, now I'm going to have to divide my expression by 2. So let's see how that works. So I'm going to put in my 0, positive 5 over 2. And then I'm going to set up my coefficients. So I've got 6 minus 19, 18 minus 20. I'm going to bring down my first term, and then I'm going to multiply them together. So 5 halves times 6 is going to be 15. I'm going to add them together. 4 minus 4. 5 halves times minus 4 is minus 10. And then I'm going to add them together. I get 8. 5 halves times 8 is positive 20. I add them together and I get 0. So my remainder is 0. This is still my constant term. This is my linear term, and this is my quadratic term. But to get my real answer, I have to divide by 2 because of this right here. So 3x squared minus 2x plus 4. And then my division statement is 2x minus 5 times 3x squared minus 2x plus 4, and then plus 0. So just any time that the 0 doesn't have, there's a coefficient in front of the x, at the end of your synthetic division, you just have to remember to divide. You don't have to do that if you're doing regular long division. The last one here, our factor is non-linear, which means that we can't use synthetic division. So you have to use regular polynomial division. So we'll set up our examples. We've got 6x squared plus 4x minus 3. And we've got 2x squared plus 0x plus 1. So it just, the shortcut does not work if you are dividing by a non-linear factor. So 8x cubed divided by 2x squared is 4x. We're going to multiply back through. 4x times 2x squared is 8x cubed. Multiply by our placeholder, we get 0x squared plus 4x. We're going to subtract. Our first terms cancel out. 6x squared is the same, and those ones also cancel out. And then I'm going to bring down my minus 3. Minus 6x squared divided by minus 2x squared is minus 3. And then I'm going to multiply through. So minus 3 times 2x squared minus 6x squared, we get 0x, and then minus 3. And we're going to subtract. These ones cancel, those ones are 0, and those ones are 0. So that means also that 2x squared plus 1 happens to be a factor of my dividend. So to complete my answer, I'm going to write my division statement, and we've got 2x squared plus 1 times 4x minus 3. And then that is it. Those are some examples of synthetic division, when it works and when it doesn't.